So in this video, I'll be talking about graphing and deriving sine and cosine functions for the AP Precalculus curriculum. The goals of this lecture is for you to be able to interpret sine and cosine functions and graphs as intuitively as possible, and being able to derive these functions from sine and cosine graphs. Now, in order to graph sine and cosine functions or derive the functions for the sine and cosine graphs, we must extract all meaningful characteristics of these functions. This includes amplitude, period, horizontal shift, and vertical shift. Now we must also understand these characteristics as intuitively as possible, because the thing with AP Precalculus is that it is meant to be a very intuitive course. Lots of the concepts we can all understand intuitively if we are given the opportunity to do so. Hence, this is what these definitions are really for. And instead of understanding the formulas, I would like all of y'all to be able to understand why they exist and why it is such. So, anyways, let's move on. So, what is a phase shift? So, a phase shift basically answers how and in which direction does the function basically horizontally shift from like a regular sine and cosine function. Basically, we are basically keeping all of the y points the same. What is the phase shift? For that, we translate all the x positions of each point on those sine cosine graphs to shift it to like a specific by a specific amount, be it to the right or to the left, or respectively negatively and positive. And next thing is what is a period. So a period answers how long it should take to complete one full cycle. And because of this, we can also say that the frequency is the reciprocal of the period, which is 1 over p. And it means how much of the cycle is completed in one unit. And the formula of this period is 2 pi over b. But why is it so? Well, basically, we can treat b as this compression factor, where basically the sine or cosine function in comparison to a regular sine and cosine function, the modified cosine function will have a b such that the full cycle takes maybe 1 over b times to complete in comparison to a regular cycle. We are transforming the period to to reduce by a factor of b. Now I know that is a handful, but it will be much easier to grasp through like one demonstration. And then the last thing I want to talk about is amplitude. So amplitude simply answers basically how far the maximum minimum point is from the midline. And in how I would like to interpret it is basically how exaggerated are the maximum minimums in comparison to the midline, or like how exaggerated the range of the sine and cosine functions are in comparison to a regular sine and cosine function. Now here is a bare bone of a regular sine and cosine function. Now this should connect back to function transformations in AP Precalculus, where compressions and phase shift and vertical shifts were covered, as well as scaling in the A and B, and shifts in C and D. And this is basically the same thing because sine and cosine are functions as well. And as you can see here, there's amplitude, compression factor, phase shift, and vertical shift. Now this will be much easier to showcase through a demo. So, pardon me, here is a demo. So as you can see here, I have a regular sine function with that same function bare an amplitude, basically a compression factor, a phase shift, and a horizontal shift. Now, one note here, I put a negative c here as well as in the function barebone, basically to convey that a positive c value is to the right and negative c value is to the left, just for that intuition and to reduce that counterintuitiveness, or if that's a word. And The first thing I would like to show is amplitude. So we have a regular sine amplitude of like positive one to negative one over here. Now, basically, amplitude means how much do you want to scale the range by? Say if now because is one times the amplitude, the amplitude of the sine function or sine function just remains the same, and the range hence remains the same by a factor of one. If we decide to make a two, now sine and cosine, now the maximum and the minimum of the sine graph now doubles. It goes from 2 to negative 2 with a total, like maybe like the range of all the values being 4. Or like the minimum minus maximum is, the maximum minus minimum is 4. Sorry. And hopefully that was a little bit intuitive. The real intuition I want to grasp is in the compression. Now the compression might seem a little bit intuitive. Well, if A is yeah, as A increases, if the amplitude increases, well, what increases in B? Well, really nothing. It's the other way around. Because say if I increase B by maybe like by a factor of one. In this case, one means like a regular sine function. Now, as you can see here, the period of a sine function, meaning the how much of the x unit is taken up by one full cycle or rotation of the sine function, is 2 pi, right? 2 pi is where basically the next cycle starts, and 2 pi k times k is when the next cycle starts, so on and so forth. But B basically answers the question, well, how much should I compress the rotation to just get that same modified value? Say if B was 2. Now, two rotations or cycles can fit in a regular sine function period. Or basically, what I'm trying to say is the period of now the modified sine function is now half of the period of a regular sine function with just regular standard values. Hence, that formula of period equals 2 pi over b is derived. And c is should be quite intuitive. It is phase shift. And basically, what we're trying to say is that keeping all the y values the same, we just want to translate all of the x values of each coordinate on the function. So yes, this should be quite intuitive. And d is basically the horizontal shift. Did I cover it? So sorry if I didn't cover it, but d is basically just the vertical shift, where basically it is the same as C, except except it is now on a different axis. It is now you're now moving it up or down on the y-axis. And well, that is how function transformations work. And it is quite similar for cosine functions, where sorry, it is quite similar for a cosine function, except as you can see here, the cosine function is pi over 2 to pi over 2 to the basically I want to say it as to the left of a regular sine function. Because, well, and that is actually one key identity and that basically really relates sine and cosine functions quite well and will become quite useful in AP Precalculus. You can search up like the full identities and like the formulas relating them later to spark your interest. But how function transformations behave in sine functions is exactly the same as in cosine functions. You have the amplitudes that behave as well as sine function. You have the compressions, right? The compression is still 2 pi over b because, well, the regular rotation takes, sorry, the regular rotation takes 2 pi to 2 pi the x-axis be one full cycle, and D we can again see B as a compression factor, and C is again a phase shift, and D is also a horizontal shift. And hopefully this video quite maybe spark your interest in graphing sine and cosine functions and deriving them, and hopefully establish some sort of intuition about graphing these functions and deriving these key characteristics. So thank you for watching this video and good luck on AP Precalculus.